Hello everyone, welcome back to this channel. In this video, we'll be solving the question we have on the board here. And if today is your first time watching this video, I want you to subscribe, like, comment, and also share this video. Now let's move on to the question we have on the board. A fish tank that contains 40 cm high water is moved in the cabin of an elevator. Determine the pressure at the bottom of the tank when the elevator is A. Stationary, B. Moving with an upward acceleration of 3 meter per second squared, C. Moving down with a downward acceleration of 3 meter per second squared. So now we have to solve, or we have to find for the pressures at these given circumstances. So our first thing to do is to get the diagram of what is here. And let's see how the diagram will look like. Since they said it's a fish tank that contains 40 centimeter high of water. So this my fish tank containing water. So this is it. So let's see the height of the water. Here is 40 centimeter. So this is the only information we have here. And we know gravity will act downwards our G. And we know also they've given us some accelerations here which will help us find the B and the C. So one will move up and one will move down. So that's acceleration equal to 3 meters per second squared. So this is how the diagram is going to be. So this will be our 2.2 and this will be our 0.1. Let me use the red pen so that. Yes, so our 0.2 and 0.1. So to find for the pressure difference, we are starting with A, the stationary one. So A, we know that pressure difference is equal to what? Rho GH. Know that the pressure difference is equal to rho GH. So for the stationary, it's very simple to go about it. Since we know it's water, we know the rho to be equal to us. Let's write it here. This is one parameter we need to know. And we know the gravity to be 9.81 meters per second squared. So since we know this, we can just go straight forward and solve for this times the height here, the maximum height, that's 0.4. And this will give us 3.924 kilopascal. So this is the answer for the stationary. So for the stationary one, it's very simple. Now let's move on to the B. That's moving with an upward acceleration of 3 meters per second squared. So this is how the equation is going to be. For our rho, it will be constant because we have to assume that the water is incompressible, so there will not be any change in density. But for the G, since they said an upward acceleration, it means we would have two accelerations here. Acceleration due to gravity plus the upward. Let's name it AZ. So the upward acceleration times the height which we have here. You get me? So this is going to give us 1000 multiplied by 9.81 times 3 times 0.4, which this is going to give us 5.124 kilopascal. So this is the answer for the acceleration which is moving upwards. So for the acceleration which is moving downwards, it's going to be the opposite of the first one since it's a deceleration. So you have to subtract. Sorry, there's a mistake here. It has to be plus. You have to subtract it from the acceleration due to gravity. So you are going to get a formula to be rho g minus az. This is what we had here. Then times h. And this is going to give us 9.81 minus 3 times 0.4, which that is going to give us 2.724 kilopascal. So this is how we go about this type of question. Very simple. So you first start with getting your diagram, then you follow along with the questions that are being asked. So any question of this form, this is how we go about it.